So the testing criteria wise, okay, they will conduct three kind of major test. Okay, the component test, sled test, and full barrier impact test. Component and sled test, it is not for BAW structure. It is in order to ensure the uh, safety structures, how it is work, like airbag systems, seat belt, okay, and ABD, ABS, like that. The safety systems, how does it works? But full scale barrier impact, that is directly impacting on the BAW structure. Okay. So I have given some of the component test and the sled test. Sled test is nothing but I will show if required. So they will pull. This is the seat belt which they are using in the vehicle. Okay. They will do the strength test for the seat belt. How much load it can withstand. So averagely, okay, we can say human weight it comes around 100 kg. So it almost has to withstand more than that. Okay, maybe before braking, it withstand around 250 kg or 300 kg load. Okay, then during the crash event, okay, this okay, our whole body weight will be shifted to the seat belt area. So whether it withstand that much load or not, that will be tested during the seat belt test. So individual system, how the airbag deploys, at which point, how many seconds it takes to withstand, that means deploy that. Okay, and the sled test means at the particular environment, okay, how the system behaves. Okay. In the sled test, they will not build a complete vehicle. Instead of that, they will build the surrounding area. This is the, for example, the bus. Okay. At particular crash test, okay, they will not build the complete vehicle. Rather than the particular surrounding area, they will create it and they will do the testing. Here, they built just a few parts of the BAW IP panel, the mannequin, and the sorry, seat belt. Okay, at particular area when the airbag deploys, okay, how much impact happened to the passenger, that will be checked in the system. For that, they no need to build the complete BAW structure or the vehicle. Here they wants to ensure the airbag, how much impact to the passenger. Okay, this is just a airbag and seat belt testing. So no need to do or no need to construct the complete vehicle. Okay, this is relevant to systems, not with the BAW structure. Okay, here we will see the full barrier impact test. These are the test conducts against the vehicle. This is offset impact test. Okay, front mobile progressive deformable barrier. That means this is the front impact test. Okay, this is deformable barrier. Okay, it looks like a, that means it acts like a another vehicle bumper. Okay, so they will not do two vehicle crash test because the crash test it's too costly. So instead of breaking the two vehicle, they will take the deformable barrier. Mobile progressive means this is movable one, movable test. Okay, so when the two vehicle come in contact, okay, how much energy will transfer to the driver, that they will check it here. Okay, this is a deformable barrier, this is movable one. Why we are doing that means call it as offset impact? Only 40 percentage of the width, okay, it is getting impact only on the driver area, not on the co-passenger area. The driver area, only 40 percentage of the vehicle width getting impact. This is fixed. That means this is not the movable barrier. This is the rigid barrier. Okay, the rigid barrier, 100 percentage full width of the front area getting impact. As I said, full width rigid barrier impact test at 50 kilometers per hour speed. The next test is a side impact test. It's also a movable barrier impact on the side area. Then this is the pole test they will conduct against the vehicle. Okay. In the highways, okay, we can see number of poles. Okay, like a signal pole or some advertisement, some bigger poles they have been kept on the signboards. Okay, like a U-turn, no parking, like that signboards they will used to keep. So the bigger poles has been seen. Okay, the light lamps. Okay, okay. For that, a number of poles has been kept on the roads. Okay, if the vehicle hit on this poles, how much impact happen? That will be test in this side pole test. This is offset deformable barrier test for the child. And pedestrian safety. Okay, here I will explain. Okay. The vehicle impact on the pedestrians. Okay, so their lower leg, thigh, and head. These are the three major impact area. Okay, so majorly injury will be happen in this area only. Their lower leg, thigh area, and head area. See this lower leg, this thigh, and head. This head will be fall over the hood or the glass area, so that the heavy injury will be happen to the head area. Okay. So this is the impact test. This is like a human head. They will conduct the test like this. Okay, the bigger ball like a human head. When it falls, okay, how much load impacts upper thigh area, lower leg area. So this will understand how much energy absorbs by the human leg on the human head. If the injury is too, that means the energy absorption is too high. That means a injury level is also too high. Okay. Apart from that, they will conduct various rollover tests. Okay. During the rollover, okay, how much impact happened to the passenger, that will be evaluated in the rollover crash test. Okay. Due to this rollover, especially the roof side area getting high injury. Like this, the multiple tests they will conduct. And finally, they will conduct roof crash test. So this is the roof strength test they will conduct. This is the roof strength test machine. Especially this is for the roof rollover test. How much load the vehicle withstand during the rollover condition. That will be ensured by this roof crash test. So various vehicle, they will conduct this roof crash test. This SWR means strength to weight ratio. At certain angle, they will apply the load. Okay, compared to the weight. For example, this is a 1300 kg weight, for example. Then how much load it withstand the complete vehicle? Okay, here around 2000 kg, 2500 kg. How much load? How many times it withstand? At least more than two times load it has to withstand. So here TSWR it's 5 times of the whole weight load it withstand. So these are the tests conduct against the vehicle, and they will ensure that whether it withstand the loads or not. So they have criteria for each and every test. Okay, so I will give some case study for that, one of the case study, so that you can understand even better. So now you understand what all the crash tests they will conduct against this BAW structure.
Yes, sir.
So these are the regulation numbers they have been given for each and every test. So this one I have been compiled one PDF that has been attached in the end of the presentation. So what all the things we have been seen in the video, okay, that has been explained over here. The frontal crash test on the full rigid wall test. This is the offset impact test. This is side impact test, pole test, rear impact test, and a roof crash test. Okay, so this now we understand what all the tests they will conduct against the BAW structure. Okay, how this we have been checking that whether whatever the structure we are creating, for example, if you are a designer for A pillar or B pillar, okay, the A pillar, the majorly, okay, it will be for frontal crash test. Okay, so this is the frontal crash test. Okay, they have been recommended 40 miles per hour speed. Okay, this vehicle hits okay only 40% of the area impact. Okay, this area the force will be transferred to A pillar and the cell area. Okay, so you design the BAW structure. First step, okay, as a designer, we are a CAD designer, we have to make a CAD model, the complete vehicle structure CAD model. That way they will integrate it. That will be transferred into CAET. They will do meshing. Then they will do full, that means the frontal crash test. They will simulate it in the simulation softwares. This is the pole test. This is the pole test. This is the side crash test. This is the roof test. This is the offset barrier impact test. Okay. So once we done the CAD model, that this area they will mesh it. This the meshing data will look like this. Like this, they have been made many nodes. Okay. Then they will conduct the crash test. Okay, for the frontal crash test, okay, our major aim is, okay, the deformation should not go beyond the A pillar. The A pillar structure has to withstand the frontal crash load. Okay, if the deformation happen more than the front this area, then this completely the structure is failure. Okay, same way for the B pillar. Okay, so this is the crash side crash test. Okay, this is the after crash. Okay, so this the deformation falls within this range. Okay, this is the original structure. Okay, if the deformation happen within this range, within this green range, then the passenger are safe. there will be a very less injury will be happen to them. Okay, this area in orange area, okay, if the crash, that means the deformation of the B pillar and the door, okay, it reaches the yellow area, then there is a minimum or minor injury will be happen. If it go to red zone, that will lead into the passenger's death. So these are the criteria for us. Okay, so when you design the structure, they will do analysis. Okay, this structure, see, this structure has been deformed within the red zone. That means huge impact happened to the driver or the co-passenger. Then the CA team give feedback to the design team that, okay, your structure is very poor. Okay, the side crash test, it doesn't pass. You need to change the material or thickness, or you need to add some reinforcement in order to withstand the crash load. Okay, I will show some case study for you. Okay, first you have been designed the A pillar structure. The complete model has been designed. You are example, you are a designer for A pillar area. This is the A pillar outer. Okay, this material is 487 megapascal. Okay, so once you have been completed, you are sharing this data to CAE team. They do meshing, they do analysis. Okay, at 0 millisecond, this is not seconds, milliseconds. 0 milliseconds, okay, here you can see there is a no impact happen. When impact happen, after that 40 millisecond, no major changes. 60, no major changes. At 80 millisecond, the load transfer to the A pillar area. Okay, during that time, okay, here the structure is getting collapsed. 100 millisecond, A pillar structure completely collapsed. The impact starting to the driver, and 120 millisecond, the huge impact happened to the driver. So whatever the structure or whatever the parts you have been defined, okay, it is not good. It not withstand the crash load. Okay, so CAE team give countermeasure to design team. Okay, so add one reinforcement. The reinforcement strength also, it should be 487 megapascal. Okay, so based on their CAE team feedback, you are designing some additional part. That is the green color part, A pillar upper reinforcement, in order to withstand the crash load. Now, after you increasing the adding the reinforcement, okay, see, 0, 40, 60 millisecond, nothing has been happened. During the 80 millisecond, okay, so the minimum impact happen. Okay, so during the 100 millisecond and 120 millisecond, the A pillar structure are rigid in order to withstand the load. See here, it getting completely collapsed. You upgrade the structure, it withstand the load. This is how the system works. Okay, first, based on your assumptions, your experience, you design the component. Okay, so when you check or when you evaluate your CAD data, okay, the CAE team, they do analysis, the crash analysis. They will understand where there is a failure. If there is a failure, they will give the countermeasure. Based on the countermeasure, you have to upgrade the structure and you have to improve your structure. Here you understand, even though there is a seat belt or the airbag, okay, when the structure is not rigid, okay, the injury to the passenger will be very high. That's the reason BAW structure is one of the key parameter to ensure the passenger safety. Is it clear? So this is just a comparison study between the CAE simulation to the CAE crash, the real vehicle. So once they do CAE simulation here, the same vehicle, once they made the physical vehicle, they will check the real crash test. They will compare it, whether it is same kind of result or how much deviation. Because every time we can't rely only on the CAE test alone. That's the reason they will check the real-time vehicle too. And in order to ensure the passenger safety, the right material selection. Okay, the BAW material selection is our responsibility. The right material selection is the key for the vehicle safety. Okay, this the material, what is the grades, why we are selecting this material for this part, that I will explain in the BAW material selection session. That is the next session which I will explain you. Okay, what is BAW materials, what are the grades they use, and why we are selecting this material grade for this part. That we will see in depth in the next session. Okay, this what is this quasi high strength or DL phase or complex phase, mild steel, everything will be explained thoroughly in the next session.